Hello and welcome students. This is Indefinite Integration lecture number 12. Lecture number 12. In lecture number 10 and 11, we had done the results, that is special integrals, and we classified those integrals in set 1 and set 2 integrals. In set 1, we had three integrals, which was 1 over x square plus a square, which we will call as variable square plus constant square dx. Then second was 1 over x square minus a square dx, variable square minus constant square, and the third is integral 1 over constant square minus variable square dx. Now, as you know, in these three, the first one looks different. It is 1 over a tan inverse of x over a plus c, whereas these two resemble each other. Their results resemble each other. And what is it? 1 over 2a log mod plus c. Here also 1 over 2a, a is a constant, log mod plus c. Inside the mod, what you have? Here you have numerator x minus a, denominator x plus a, and here it's a plus x and a minus x. So this is set 1, 3 results. We are going to use these results to solve problem. So please keep this in mind and write these several times so as to remember them. Then we had set 2 results. In set 2 results, we had done, the first one was integral 1 over square root. What's the difference here? Now we have x square plus a square inside a square root. So 1 over square root x square plus a square. Second is 1 over square root x square minus a square dx. And third is integral 1 over square root a square minus x square dx. Okay, so here also three theories, and we found that the third one looks different, and these two, first and the second, resemble each other. What is third one? The third one result is sine inverse of x over a plus c. So remember, if you have 1 over constant square minus variable square, then it is sine over variable upon constant, and these two resemble each other. What is it? You have log mod plus c, and here also log of mod plus c. Now inside the mod, what you have? You have two terms. One of them is the variable itself. What's the variable, students? The variable is x. So you write x plus. Here also you write x plus, and then you copy the whole square root which you had in the denominator. So x plus, copy the square root, x square plus a square, and here you have x square minus a square. This is 3 results. Now we can start solving problems. So I'm taking, let's take few questions here. Very interesting problems these results are going to give us. So the first one is, let's start with the problem. Question number 1. So the first question here is, I have to evaluate question number 1. I write this as let I equals to integral 1 over 4x square minus 3 dx. 1 over 4x square minus 3 dx. So what do I do? Students, you know, integrating a given integrand, this function, if I want to integrate, what I need to do is I need to apply the proper result. Okay. Now in last two lectures, we equipped ourselves with few more results. Total 6 more results we now have in our list. 6 more results we have. Okay. Which 6 results we have? These 3 and these 3, right? So what I have to see here is which one of those 6 results are applicable here. So see, before I apply the results, I would like to write this in exactly the way the results are. So here 1 upon, I write 4x square as 2x the whole square, okay? And 3 I can write minus root 3 square. And then what I have, dx, okay? Now I notice it is in the form 1 over, it is in the form 1 over variable square minus constant square. It is in the form variable square minus constant square. And where is that? See here, students, this is the one I'm talking about. I can apply this result here, variable square minus constant square, okay? Now in this result, you notice that the variable is x. The variable is x. You are integrating with respect to x. This is the result to be applied. Okay, this result. And remember students, these results are very specific. Like I have 1 over x square minus a square dx. So remember, once it is x square minus a square dx, you cannot have anything other than x. You cannot have anything other than x. Okay, that is for sure. But if you remember, there was one theory we had done long back, and the theory said that if x is replaced by any linear algebraic expression, then the theory still holds true. Okay, the theory still holds true if x is replaced by any linear algebraic expression. Okay, I repeat the whole thing once again. These results which we have written, all these results are very specific. Now what does that mean, being specific? Being specific means in this integrand, the function that you are integrating, any one of these integrands, wherever you see x, remember it has to be strictly x. Why? Because here you have dx. So since you have dx, these all have to have strictly x. Okay? But then there is a concession. Concession for px plus q type, that is linear algebraic expression type. You say px plus q or you say ax plus b, it hardly matters, both are same. Okay, both are same. So x can be replaced by ax plus b or px plus q, nothing else. So here what do I have? I have variable square minus constant square, and the variable is not x, it is 2x. Is it allowed? Yes. Why allowed? Because x is replaced by 2x plus 0. See, 2x plus 0, px plus q is 0 here, so it is still allowed. Okay, so see what will be the answer. The answer is 1 over 2a, you can check here, 1 over 2a log of variable minus constant upon variable plus constant. So here I write 1 over 2a, a is root 3, log of variable minus constant. So 2x minus root 3 upon 2x plus root 3 into 1 upon 2. Now why this 1 upon 2? It is because the coefficient of x is 2. The coefficient of x is 2. Whenever we notice while applying the result, the step where you are applying the result, if you have x coefficient other than plus 1, then you will always divide by that. It is x coefficient 2, so we divide it by 2 plus c, plus c. So the final answer you have is, the final answer you have here is 1 over 4 root 3. This 2 multiplies this 2, 4 root 3, log of 2x minus root 3 upon 2x plus root 3 plus c. This is answer. Okay, I hope you all have followed this. You can once again see this question solution once again. If in case of any doubt, you can write it in the comment section. I shall revert it to. Thank you. Okay, so students, you can have for practice one question here. I write for you. You can practice this question. This is integral 1 over 25 minus 9x squared dx. You can practice these problems on your own. I take the third one. The third one is let I equals to integral 1 over 7 plus 2x squared dx. So once again, integration is all about application of result. I noticed that I could apply a result here, that is 1 over variable square plus constant square. I could apply that result 1 over. So I need to write in that form. So root 7 square. I must have constant square, and one term should be constant square. The other has to be variable square. So it is root 2 times x the whole square and dx. So which result is applicable here? 1 over variable square plus constant square. See, the first one here, I can apply this. 1 in numerator, 1 is compulsory. You need to have 1. And the denominator here, we have variable square and constant square. So the same thing is applicable here. Okay, so what is the answer? 1 over a tan inverse of x upon a. So 1 over root 7 tan inverse of root 2x upon root 7 and multiplied by root 2, 1 upon root 2. Why multiply by 1 upon root 2? It is because we need to divide by root 2, because while applying the result at a stage where you are applying the result, you notice that there is a coefficient of x which is other than plus 1. So you need to divide by that. Okay, at this stage you notice that coefficient of x is other than plus 1. I say this once again. You need to follow this at a stage where you are applying the result. I am applying result at this stage. So at this stage, whatever coefficient I have, I will divide by that. Some students, they think the coefficient is 2, which is wrong. You are not applying result at this stage. No, you are applying result here at this stage. So here, what's the coefficient? The coefficient is root 2. So you divide by root 2 and then plus c, you write plus c. So the final answer you get here is I equals to 1 over root 14, because root 2 multiplies root 7, tan inverse of root 2x over root 7 plus c. This is final answer. Now we have the fourth one as let I equals to integral 1 over root of 3x square plus 8 dx. So what do I write for this? This time I have got square root in the denominator. So I understand that it is going to be the second set theories which we are going to use. So I will write it exactly in the form the theories are. So I write variable square. I need to have a variable square and a constant square. So I write here root 3 times x the whole square, and this is 8. What is 8? 8 is 2 root 2 the whole square. 8 is 2 root 2 the whole square and dx. So I have here, now this is 1 upon square root variable square plus constant square. So from the three theories that we have done, if you remember, it is this one which we are going to use. We are going to use this one, 1 upon square root variable square plus constant square. Okay, and what is it equal to? It is equal to log mod of variable plus the square root as it is. Okay, So what is my variable here, students? The variable we have is root 3x. The variable is root 3x. So the answer will be log mod the variable, which is root 3x, plus the whole square root as it is. The whole square root as it is. Root 3x square plus 2 root 2 square. Okay, into 1 upon root 3. Once again, why this 1 upon root 3? Because coefficient of x is root 3. So I need to divide by that, plus c. So the final answer which I will get here is, the final answer is I equals to 1 over root 3 log of, I write this 1 over root 3 in the beginning, 1 over root 3 log of mod root 3x plus square root of, and as you know students, root 3x the whole square is nothing but 3x square, and this is 8. So 3x square plus 8. This is the answer. You can see this solution once again. Okay, having done this problem, there is something more I would like to say on this solution. So what we solved here could be one method of integrating this function. There is an alternative method which I will now apply. So let me solve the same question by alternative method. So what the question was, students, it was I equals to 1 over square root of 3x square plus 8 dx. 3x square plus 8 dx. Yes. Students, what we can do is right in the beginning, that is in the first step itself, I can take 3 common from these two terms. What I say is, from these two terms, 3x square and 8, I can take 3 common. Now, if you have a question that why do we do that, the simple answer could be, I want to make the coefficient of x square 1. I want to make the coefficient of x square positive 1. That is my aim. Okay. So when I take 3 common, see what do I get? I will get 1 over square root of, I take 3 common. So here I get x square over, I'm sorry, I take 3 common. So the first term is x square and the second term is 8 over 3. I hope you understand why 8 over 3, because there was no 3 here. So when you take 3 common, you will get 3 in the denominator. Okay, this is very simple mathematical step. I hope everybody understands this. So from 3x square plus 8, when you take 3 out, so here you get x square inside the bracket plus sign, and then you get 8 by 3. Now this 3, as you all know students, root of AB is root A multiplied to root B. So here this will be 1 over root 3 out and root of x square plus 8 by 3 and dx. So next step, what I can do is, next step, I have here, therefore I equals to, this root 3 is a constant without any x, so this 1 over root 3 will go out. So 1 over root 3 and 1 upon square root of, now what do I need? I need variable square and constant square. So this is x square plus this one 8 over 3, I'll be writing 2 root 2 upon root 3. As you know, I need to write in the form square where I get a constant square. So variable square I already have. I need to have the another term as constant square. So 8 over 3 is written as 2 root 2 over 3 over root 3 the whole square and dx. Now I can say I have the result, to 1 over square root of variable square plus constant square. I have the result 1 over square root of variable square plus constant square. So therefore I equals to 1 upon root 3, and here we will apply the theory. What was the theory? It is 1 upon square root of x square plus a square. So 1 upon root 3 log variable. What is the variable? The variable is x plus the whole square root as it is. Square root of x square plus 2 root 2 by root 3 square plus c. And mind it, students, that this time, since I have x square, I have variable square, where the variable is x only, there is no coefficient. Mind it, students, that when I'm applying the result at this stage, okay, the variable has coefficient plus 1. Unlike the previous method, when we applied the result, we had the variable coefficient as x coefficient was root 3. So we had to divide by root 3. But in this case, what we noticed that x has coefficient plus 1. So I did not divide. But don't worry, because everything gets compensated. See that you had divided and later you had got outside, but here it is already there. You understand? So it's doing one thing in different ways. It's doing one single thing in different ways. So here now I'm not going to divide by any coefficient. I just explained you how. Now the next step you get is 1 over root 3 log, and here you have x plus square root of x square, and this, as you know, student, this is 8 by 3 plus c. So here I'm getting answer as this, whereas the earlier answer looked like this. Now see, students, if you check these two answers at the very first sight, you will find that these two answers are different. You can check 1 over root 3 log of root 3x, but here you know you don't have root 3x, you have simply x. But don't worry, students, because here you got 3x square plus 8, while here you have x square plus 8 by 3. So the thing is, when you work on these two answers, like if I start working on this answer, I will get the answer that I had got by the first method. Or if I work on the first answer, then I will reach this answer. So both the answers are same. The only thing is they look different because we had a different approach for solving them. I hope you have understood both the method. You can just find how interesting these two methods are. Write these solutions again and again, practice them well. Thank you. So let's take one more question for practice. And this question is for practice for you all. You will try this. Integral I equals to integral 1 over square root of 2x square minus 5 dx. You can use the method which you prefer. Either of the methods are equally correct. I'm solving for you one problem, that is number 5. 1 over square root of 11 minus 4x square dx. Okay, I shall be solving by the first method, where I don't make the x square coefficient 1. I don't make x square coefficient 1. I leave it the way it is. Okay, I am deliberately taking that method because I want you all to be aware that if the x coefficient is other than plus 1, then you have to divide by that number. Okay, so deliberately I'm making you aware of that. So here, see what I will do, students. It is 1 upon 11 minus 4x square. I will write this as root of 11 square minus 2x the whole square, and dx. Then here I have, so here I shall get I equals to, now this is in the form constant square minus variable square. This is constant square minus variable square. So in set 2, students, it is the one which I had told you that it has a result totally different. It is not resembling the other two. 1 upon a square minus x square dx. If you remember, it was sine inverse of x over a, that is sine inverse of variable upon constant. So by this, what would we write? We will write sine inverse of 2x upon root 11 and into 1 upon 2. Into 1 upon 2. Why this 1 upon 2, students? Because x coefficient is 2. That's why we need to divide by 2. So the final answer here is 1 over 2 sine inverse of 2x upon root 11 plus c. This is answer. Okay, I hope you all have understood. This change is there is a slight change in question number 7. The change is making the question quite interesting. See, what is it? It is square root of 9 plus x over 9 minus x. I need to integrate this, and I notice that it is none of the results that we have done so far. And you remember, students, integration is all about applying the result. When you see an integrand and you notice that you are unable to apply a result, what do? Yes, you rightly said. The word is transformation. Rightly said. The word is transformation. What we do, we bring in transformation. We transform the given integrand. We transform the integrand in such a way that where we can apply the result.
सर आप म्यूट में थे।
सर कुछ सुनाई नहीं दे रहा।
Okay, so what we do, students, here for getting the transformation, for transforming this into a form where we could apply the result, I multiply the numerator and denominator by numerator. That is, so 9 plus x I multiply in numerator, and 9 plus x I multiply in denominator. Okay. Now what does this do to me? Okay, this gets me the numerator a complete square. This gets me the numerator 9 plus x the whole square, whereas the denominator, it gets me 9 square minus x square. A minus b into a plus b, you know, a square minus b square. So I get 9 square minus x square dx. 9 square minus x square dx I get here. So the next step I get is I equals to, so the sole aim I had for multiplying the numerator expression in numerator and in denominator was, I wanted to make numerator radical free. I did not want the square root in the numerator. Now you can check, because you multiplied 9 plus x up, you got 9 plus x square, and now this is outside the square root and it is just 9 plus x. Whereas you will get the square root in the denominator, and that is 9 square minus x square. This is what you now get. Okay, so the denominator, you notice it is in the form constant square minus variable square. It is in the form square root of a square minus x square. It is in the form square root of a square minus x square. But remember, students, we cannot apply the result because the numerator needs to be 1 in order to apply the result. If you remember, the theory said that if it is 1 upon a square minus x square, then you write sine inverse of x over a. Sine inverse of x over a you write, but here it was not sine, it is not 1. This needs to be 1 in order to apply the result. So what do I do? For that, I will have to go ahead and I need some more working on the integrand. So see, the next step I do is I now split the denominator. So this gets me 9 over square root of 9 square minus x square plus x over square root of 9 square minus x square and dx. It gets me this. Then next I will write separate integral. So this is 9 times integral 9 times square root of 9 square minus x square dx plus integral x over square root of 9 square minus x square dx. Now what I notice is in the first integral, I notice that in the first integral, it's going to get integrated in the very next step. Whereas the second integral, it's not going to happen in the next step. Why so? See, in the first integral, I have got a constant 9 in numerator. So the moment I take it out, 9 is a constant. It can be written outside the integral sign. So when I write this out, I will be left with 1 here and then I can apply the result. But in the next integral, the second integral, I notice this is not a constant, it is x, and hence I cannot take it out. No, this is not allowed. You can't take a variable outside the integral. Okay, so here I notice that this is going to get integrated in more than a step. So what I do is I will write this as I equals to I1 plus I2. Okay, when I realize that there are more than one integrals which are going to get integrated in different stages, I will write them as I1 and I2. This is my equation number 1. Now I consider what is I1. I write here I1 is integral 9. So 9 is out, and 1 upon square root of 9 square minus x square dx. This will get me 9, and here I can apply the theory. The theory is now applicable because it is 1 upon square root of constant square minus variable square. So that is sine inverse of x over 9 plus c1. This is I1. I write this as 2. So I1 is obtained. I got I1. Now I'll work on I2. What is I2? I2 is x divided by square root of 9 square minus x square dx. This is I2. So we got the second integral, that is I2, as square root of integral x upon square root of 9 square minus x square. What I do here is, it reminds me one very important result which we had done in earlier videos, and it was f dash x. It was f dash x upon square root of f of x dx. If we have an integral where the numerator happens to be derivative of content of the square root. Inside the square root, in denominator you have f of x, and the numerator is derivative of f of x. So its integral is 2 root f of x plus c. This result, very important result. So we are going to use this. But for using this, see, what does this result say? It says that the content, the expression that you have inside the square root in denominator, its derivative we should get in the numerator. So here I have the expression inside the denominator. The expression inside the square root in the denominator is 9 square minus x square. Derivative of 9 square minus x square is minus 2x, because 9 square is a constant, its derivative is 0. So I will have to write numerator as minus 2x. So here I write minus 2x. Okay, and since I write numerator minus 2x, that is I multiply negative 2, I will divide by negative 2, and the denominator I keep as it is, 9 square minus x square dx. Now you all know, students, why this negative 2 I multiplied in numerator. This negative 2 I multiplied so that I will get negative 2x in the numerator. I will get negative 2x in the numerator. And since I multiplied negative 2, I divided also by negative 2. Now I can say that this result is working here. Okay, what is that result? Derivative of the expression inside the square root in the denominator is present in the numerator. So I write here using this result, and this will get me the I2 as minus 1 upon 2 square 2 times square root of 9 square minus x square plus c2. C2 because it is I2. What is integration of this whole thing? What is integration of this whole thing? It is 2 root f of x. F dash x, f dash x upon root f of x. This is f dash x and this is f of x. F dash x upon root f of x is equal to 2 root f of x. So this minus 1 upon 2 I wrote here, and then 2 root f of x, 2 root f of x, that is 2 times root of 9 square minus x square. So the next step is this 2 and 2 cancels. What I get here is I2 I get as negative square root of 9 square minus x square plus c2. This is equation number 3. I write using 2 and 3, 2 and 3 in 1. We get, what do we get? We get I equals to, I was I1 plus I2. I was I1 plus I2. So I1 here I got 9 times sine inverse of x over 9 plus I2. What is I2? I2 is this negative 9 square minus x square plus C2. Okay, so remember students, here you had C1 and here you have C2. C1 plus C2 will get us C. So this is my final answer. That completes the solution. You can write here where C1 plus C2 is equal to C. This is the final answer. I hope you all have understood this. See the solution once again. You can have two problems for practice. You can solve this question, then you can solve one similar problem. There are two similar problems rather. Integral square root of 2 plus x upon 2 minus x dx, as you had here square root of 9 plus x upon 9 minus x. You can have this square root of 2 plus x upon 2 minus x dx, and you can also solve integral square root of 10 plus x upon 10 minus x dx. And the answer of this will be, like here you had 9 times sine inverse of x by 9. So in this you will have answer as 2 times sine inverse of x by 2, and then minus 9 square minus x, square root of 9 square minus x square. So this will be minus square root of 2 square minus x square plus c. 2 square minus x square plus c. Similarly, you will get the answer for this also. You understand that like here you had 9 everywhere. In this you will have in the answer 2, and here in the answer you will have 10, because everything else is same in the question. 2 plus x upon 2 minus x, 10 plus x upon 10 minus x. And the question that we solved, it was 9 plus x upon 9 minus x. So nothing has changed except the numbers. These two problems you will try. These questions are quite important questions, so you should try them all. So this is the end of today's lecture, students. Thank you so much.